Two negative charges, A and B, are placed at the corners of an equilateral triangle. What is the magnitude of the net electric field at point C? In the previous problem, we figured out that the field due to A would look like this at point C, and the field due to B would look like this at point C. So if we break that down into components, we know that these x components are going to cancel out. However, the y components are not. So we have E, magnitude of the electric field here. We have another vector there. What is the length of that y component? All right, well, what are the angles at play here? We have 60-degree angle here. And here, if we make little axes, this is a right angle here. So if that is 30, which is half of this whole thing, if this little angle here is 30 degrees, that means this angle in here is 60 degrees. I'm actually going to make this bigger. So this is this thing right here zoomed in on. And so this is E. This is the x component, which is going to cancel out with the other one on the other side. Here is the y component. So we need to know the length of this vector. Using trig, we know sine 60 equals opposite over hypotenuse. This is a right triangle. So therefore, that is the y component divided by the hypotenuse, E. Therefore, the y component is E sine 60. Now, sine 60 is the square root of 3 over 2. So this is the magnitude of the y component of one of those vectors. If we want both of them, we're just going to multiply this by 2. So the 2's cancel, and we see that the net electric field is going to have a magnitude of the square root of 3 times E. Now, what is E? The electric field due to a charge is KQ over R squared. So this is what we plug in here, and we see that that is B, the square root of 3 times KQ over R squared.